This is the lesson for Chapter 6, Section 4, Comparing Linear and Nonlinear Functions, day number 2. So what we're looking at today is the definition of a function, a linear function that is, and linear, if you look at that first 4 letters, we see the word line, and that's what a linear function is. It's a line when we graph it. And if we're just looking at the function itself, what we're looking at is 2 variables. So it's a function in 2 variables, both raised to the first power. So what does that look like? Well, here's some examples. If I had 2x plus 3y equals 6, this is a linear function because I could rewrite this as 2x to the first power plus 3y to the first power equals 6. So a little rule of function with variables and their exponent is if you don't see the exponent, it's raised to the first power. So something that also would end up working would be something like this. Let's say it was just x equals a number, like let's say 3. See, this looks like it's only one variable, but I could rewrite this as 0 times y plus 1x equals 3. That's the same exact thing. And notice how both variables are raised to the first power. Same thing if it just said y equals negative 2. That can be written as 0x, 0 times x makes 0, plus 1y equals negative 2. And again, both numbers are to the first power. So it could even look like this. Let's say it was y plus x equals maybe 2x minus 4. So it looks like I got more than one variable, but actually I really only have 2. See, if I go ahead and simplify this, I can subtract the x from both sides, and I've now got y equals x minus 4. Now, all of these problems always had the variables to the first power, and that's what makes them linear. So we're going to look at some questions in which they're asking, do the equations below represent a linear or nonlinear function? And then we'll have to explain. So our explanation, if they do, is this. Both variables are raised to the first power. So that's what we're looking for. So here I see 1/3 times x. Notice how x is in line with the fraction bar, so it is raised to the first power. However, the y is not raised to the first power. It's raised to the second power. So we would say this is nonlinear. Nonlinear because the variable y is not raised to the first power. And so looking at this next one, it is a linear function because remember how we had that other example there. I subtract x from both sides, and then I've just got y equals x plus 9. And so I see that both of these variables are to the raised to the first power because I don't see the exponent, so that's what I say they are. It's just raised to the first power. So if you don't see an exponent, it's just raised to the same first power. And that goes with anything, not only variables, but numbers as well. So linear because both variables are raised to the first power. So looking at this next one, I see that x is not in line with the fraction bar. So this is actually something different. We'll talk about exponent rules towards the end of the year. But what this represents, whenever x is in the denominator, this is the same thing as saying 3/4 times x to the negative first power plus 2. We'll see why that is later on. But whenever x is in the denominator, it's not to the first power. It's actually to the negative first power if we go ahead and move it back up into the numerator or in line with the fraction bar. So we would say this is nonlinear, nonlinear because x is raised, or we'll just say not raised to the first power, is not raised to the first power. And looking at this next one, notice how this time it looks like the same problem, but notice where x is. X is in line with the fraction bar. So again, this is the same thing as x is to the first power and y is to the first power. Because it's not underneath the fraction bar, it can be on top of the fraction bar, so this is okay. So if it was 3x over 4 plus 2, this is okay. This x is still to the first power. It's only when the x is in the denominator where it would be nonlinear. So this is linear. Linear because both variables are to the first power. So let's take a look at some other types of problems we'll experience, and here they are. You find the missing value that makes the table represent a linear function, and then it says we're going to also write the linear function. So we have two things. We have to find this missing value and then write the function. So the first thing I'm going to end up doing is I'm going to use the slope formula. So remember, our slope formula goes this way: y minus y1 over x minus x1. So remember, the y's are on the bottom of the fraction here, so I have to put those on top. Negative 2 minus 0 over 2 minus 6. That makes negative 2 over negative 4. So if I reduce that, the two negative signs cancel out and make a positive. Now I'm going to use point slope. So remember, point slope goes this way: y minus y1 equals m times x minus x1. So I take the slope I have and I use one of the points. I'll just use this point right here. And so I plug in y minus 0 equals 1/2 times by x minus 6. So I go ahead and distribute, and y minus 0 is just y, and I have 1/2 x minus 3. So I took half of 6, and that's what I got. So once I've got the function, that's the linear function. So now I'm going to find out what the question mark here is. So I'm going to input 4 in for x. That's why they call that the input. You input 4 in for x, and when I do that, I take half of 4 as 2. 2 minus 3 makes negative 1. And remember, that's what a function is. You always get the same answer. So let's write down y equals negative 1 when x equals 4. That was our solution there. So on this one, same sort of thing. We're finding the slope. So 5 minus negative 3 all over negative 2 minus 2. So I'll add the opposites, and I'm left with 8 over negative 4, which makes negative 2. And so from that point, I'll take a point. I'll take this one right here. So I have y minus negative 3 equals negative 2 times by x minus 2. So I distribute. This is going to be a y plus 3 equals negative 2x plus 4. Positive 4 because of the two negative signs there, and I subtract the 3. So I'm left with y equals negative 2x plus 1. Opposite sign, so I subtract it. So from that point, I input. So I'll input the x value, which is 0, in for x. And negative 2 times 0 plus 1. Well, negative 2 times 0 just makes 0. 0 plus 1 makes 1. So y is 1 when x equals 0. So moving on to this next one, same sort of thing. We're going to find the slope. So I'll do 11 minus 17 all over 6 minus 8. So when I do that, I get 6 over 2, negative 2 that is, and both are negative really, and so that's going to make a positive 3. And so two negatives again make a positive. So I'll take a point. We'll just take this point right here. So y minus 11 equals 3 times by x minus 6. So I'll distribute, and I've got that y minus 11 still equals 3x minus 18. So when I go ahead and add the 11, the negative 18 plus 11 makes negative 7. And then I'll bring down the 3x, and this all equals y. So I'll take the input of 6 and put it in for x, and then take away the 7 and see what I get. Oops, actually, that would give me the same answer of 11. So we want to input 7 this time, because that's the number that we're trying to put in there. So let's go ahead and fix that. So we'll put in a 7 there. That makes 21, and 21 minus 7 gives me 14. So y is 14 when x equals 7. And then the last one here, so again, our finding the slope, negative 13, take away negative 7, over negative 12, take away negative 4. So I'll add the opposites, Notice how I got more negatives and positives. This makes a negative 6 over a negative 8. Well, that reduces down to 3/4. So that's the slope I'm going to use. So I'll take one of the points. I'll take this point here since it seems smaller. And I've got y minus, and then I'm going to write down y minus negative 7 equals 3/4 times by x minus negative 4. So I'll add the opposites. So I'm left still with that y plus 7 equals 3/4 times by x, and so I'm going to go ahead and write that next to it now, 3/4 x, and this 4 cancels out and changes to a 1, so the 4's cross cancel, so 3 times 1 gives me 3. So when I go ahead and subtract the 7 from both sides, I'm left with y equals 3/4 x minus 4. So that's the function. Now we're going to find out what y is when x is negative 8. So y equals, or 3/4 times by negative 8, and then minus 4. And so I go ahead and do some cross canceling. This makes negative 2. When I multiply across, I get negative 6. Negative 6 take 4 away, makes negative 10. Same sign, so I add. So that's what you get when x is negative 8. So those are the problems that you're going to see on tonight's assignment. Good luck.